Which of the rows in this table lists the correct masses for argon? And when we look on the periodic table, we see argon, which has an atomic number of 18, has an average mass of 39.95 grams. So what we want to do is look at this and how it relates to one single atom versus 1 mole of atoms. So if I'm looking at or talking about just one single atom, then this number represents the atomic mass units of just one atom, which means that is the atomic mass within the nucleus of just one atom. And so, for example, if I had roughly 20 protons and 20 neutrons, then together that would equal 40, which would represent my atomic mass units. But of course 39.95 is representative of an average of what you would find in all of the atoms of argon. We also can use this average atomic mass in terms of 1 mole of atoms, or 6.022 times 10 to the 23rd atoms. For every 1 mole of atoms, argon atoms, it is equal to this average mass of 39.95 grams. So, if I wanted to know how many grams does just one single atom weigh, then I would say one atom is equal to how many grams when 6.022 times 10 to the 23rd atoms is equal to 39.95 grams. So it's kind of a proportion that I've set up here. And so we'll take 1 times 39.95 and then divide by 6.022 times 10 to the 23rd, and I get a mass of 6.634 times 10 to the negative 23rd grams. So one atom has this mass. How many atomic mass units total are there if I'm dealing with 1 mole of atoms? Well, if one atom is equal to 39.95 atomic mass units, then 6.022 times 10 to the 23rd atoms would be equal to how many atomic mass units? So I can set up that proportion, and we'll take 39.95 times 6.022 times 10 to the 23rd divided by 1, and we get 2.406 times 10 to the 25 atomic mass units. So my final answers are that one atom is equal to 39.95 atomic mass units, and one atom would be equal to 6.634 times 10 to the negative 23rd grams. But if I had 1 mole of atoms, then they would have an average mass of 39.95 grams, and they would equal in total 2.406 times 10 to the 25 atomic mass units, which is letter B.